Yes, sorry, there's no froth involved in those SuDs because that's SuDs as in sustainable drainage systems. So there's going to be plenty about water, but there won't be any soap involved. And after that, we're going to follow up with a brief presentation by Richard Taverner of the Hearts and Beds chapter, or they're not Hell's Angels, but it's the local organisation for the Constructing Excellence, which is a national organisation. And he will be joined by Alison Nichol and Phil Henry, who are part of the National Constructing Excellence organisation. So there's a hell of a lot to get through, tight timescales. Let's get cracking. As usual, can you put questions on the chat? I fear we may not get time to answer many of them today, but as always, we will follow up with a mail shot to everybody who attends so that any questions will get answered in due course. So without further ado, take it away, Les.
Good afternoon, everybody. I'm having to cut this short what I originally organised, so I apologise for the briefness of this. I'm going to try and stick to principles. What the nice thing is about it is that it's going to be recorded and you're going to have the opportunity to go back and look at the recording should there be anything in there that doesn't make any sense, or alternatively run through the questions. So this is an introduction to SuDs, sustainable urban drainage. I don't know why they call it urban. It could be rural drainage. Who really cares? It's just drainage, surface water disposal. These are the pillars of SuDs. In the rehearsal, I said pillows, but they're not. They're actually pillars, and there's 4 of them: quality, quantity, amenity, and biodiversity. You could apply that to life, but in this case, we're going to apply it to SuDs. Now, I'm going to concentrate on quantity and quality, and the amenity and the biodiversity tends to take care of itself to a certain extent. But let's go on to quantity for a second. Now, if you take only 2 things away from this, it's the fact that the volume of water is going to hurt you and the peak flow is going to hurt you. So low intensity duration rainfalls that provide a lot of volume, which is typically the 100-year 6-hour storm, or the peak events, the short high intensity events, they're going to hurt. Now, the high volume stuff will create something that's similar to the photograph that you saw on the introduction. The peak flow tends to pop the manholes off as the drainage systems tend to overflow. In relation to quality, we're looking to avoid getting 3 aspects into the system. The suspended solids, which is generally the silts, and sediment are SuDs' biggest enemy. So whatever you try and do when you're designing SuDs, you've got to be able to design it so you can so you can actually maintain the sediment. Then on top of that, we've got heavy metals, and on top of that, we've got hydrocarbons, which is very much similar to site investigations. In relation to good design and taking advantage of surface water runoff and using good design to take advantage of that fact. And then when we get to biodiversity, my philosophy is if you get the other points right, the biodiversity will take care of itself. The wildlife is amazingly adaptive, and it will infiltrate our lives whether we want it to or not. What I was going to do to start off with was try and give a guidance to the legislation. And although SuDs is considered more for the big schemes, we've been adopting SuDs for a million years now. A soakaway is SuDs. It's an infiltration device, and H3, requirement H3, the building regulations, is very clear about the way that we get rid of surface water. It's got a hierarchy just the same as the SuDs manual does, where we look to first to infiltrate, then secondly into a water course or a water body, and third into a sewer, but it doesn't identify any sewer, just says a sewer. The SuDs manual is a little bit more, well, I'm saying a little bit more detailed, but it's along the same lines. With Wales also has added to that list is collection for use, because infiltration can be sometimes difficult in Wales, because you may be your site may be on bedrock, and it's very difficult to infiltrate into that. So we try and use it where we can, i.e. with rainwater harvesting. And then we have infiltration, surface water body, surface water sewer, combined sewer. So the legislation from the building regs is the same as the non-statutory guidance of the SuDs manual. So let's try and combine them together and give you guys some kind of idea of when you're going to be using soakaways and infiltration devices for the building regs, and when it's going to kick in and you're going to need to use SuDs as part of the planning process. So up to 25 square meters of roof area, we're looking at a soakaway, and the design is 10 millimeters of rainfall in 5 minutes. So it's quite an intense event that it's designed to, that soakaways for up to 25 square meters are recommended to be designed for. So don't be surprised if they overflow. They're almost designed to fail. So when people turn around to me and say, well, I don't want to use the soakaway because it won't work in this, in this soil, I say, well, they're not designed to work all the time. A 10-minute rainfall for 5 minutes is probably once every 6 months. So if it doesn't fail once every 6 months, it's doing extremely well. Now, if you're between 25 square meters and 100 square meters, then you're looking for a rectangular soakaway in accordance with BRE 365, and you're looking at a 10-year return period to design it to, with a number of durations of storm events. So you're looking at an event that may happen, that has a 10% chance of happening every year. So it's not as if that storm's only going to happen, is going to happen once in 10 years. It stands a chance of happening 10% of the time in any year. So again, it stands a chance of overflowing if it's designed onto the limit. Over 100 square meters, you're generally looking for a trench soakaway there. And again, the same principles, 10-year return period, you're looking for, I shouldn't have done that, 10-year return period with a number of durations dependent upon the design. Now, SuDs kicks in when the project's major, and the definition of a major project is 10 or more houses or the commercial equivalent. Now, that's what the guidance says, and that's generally looked at as 1,000 square meters of roof and paved area. But to be fair, like I said, it's the wording in the guidance in the planning framework is commercial equivalent. So you really need to talk to the planners when you've got a scheme and figure and do a little bit of pre-application advice on that. And it's always good to do the pre-application advice on SuDs because each county has its own SuDs manual as well as the national SuDs manual, and that will be based upon the local hydrology of the area. So it will change from county to county. Of that, I've got no doubt. We're looking to try and get 5 millimeters of interception, and what that means, we'll do a little bit more about interception later, but 5 millimeters of interception means we're going to dump 5 millimeters of rainfall into our surface water disposal system, and we don't want to get any discharge into the receiving water course or the receiving waters or the receiving drain. So we try and infiltrate that, we try and evaporate it if we can. The return period for SuDs is 30 years for no surcharge of the drains. So now you've got a 3.3% chance of it surcharging per year. So we reducing the chances of a surcharge, i.e. the manhole covers popping off. And the second condition is the 100-year return period, which is the one in a 100-year event, and that could possibly happen 1% of, it stands a chance to happen 1% of every year. Now, what that involves is what's called exceedance. So the site's allowed to flood, but the dwellings and the buildings are not allowed to flood. So you might get 50 or 60 millimeters of surface water appearing on the hard surfaces, and that hopefully should be directed towards the open spaces or in areas where it's not going to cause any problems. And you'll see occasionally on development, you'll see curbs where curbs shouldn't be there. And the reason for that is it's directing the exceedance to where it's designed to be directed. So that's the reason for the curbs sometimes, obviously not always the case. Little bit of a chat on soakaways. Regardless of the size, the benefits and the disadvantages are the same. It's an infiltration component, it's a storage component, and it provides some treatment in relation to quality. And it acts the same way as a big attenuation tank, exactly the same if you think about it. You can have large quantities of water coming into it, but there's only small quantities of water that's going to go out of it. So the whole SuDs thing is based upon a soakaway, basically. Even though HR Wallingford would clip me around the ear for saying such a thing, because there's much more involved in it than that. In relation to the design, this depends upon the inflow and the subsoil. So, and the storage equals the inflow minus the infiltration. So if you've got 10 litres per second coming in, and you've got 1 litre per second going out, then you've got to store 9 litres per second for the duration of the storm. It's really as simple as that. The other aspect of it should half empty within a reasonable period of time to deal with the next event. That makes sense. The thing fills up because it's dealing with an extreme event. If something else happens, it's going to fail almost instantly. So there's a bit of common sense involved in that. This had me rolling around on the floor this morning. It was sent to me for comment. That's supposed to be a soakaway, and instead of wrapping it in geotextile membrane, they wrapped it in polythene and effectively made, I don't know, an underground pond, I suppose, because it's got no outlet. So things do go wrong occasionally, and that's basically something that went wrong. I blacked the guy out in the photograph, so just in case anybody thought it was his fault, and I'm sure it was. Right, okay, a little bit more about soakaways design. Soakaways are designed to BRE 365. Now, all the data relating to rainfall characteristics in this country are based upon a 5-year return period storm with a 60-minute event. And that, for all of the country, is 20 millimeters. So that's 20 millimeters of rain all throughout the country. It doesn't alter. All the return periods and durations are factored from that data. So, and when a soakaway is designed for a M10, which is a 10-year return period, 2 factors are applied. The Z1 effectively deals with the location of the soakaway and the soil characteristics to a certain extent, and the Z2 deal effectively factors the 20 millimeters up or down. So if it was an M10 storm, then it would factor that 20 millimeters down. If it was an M10 60-minute storm, it would factor that value at that 20 millimeters up. Now, as per usual, what's happened is we're doing SuDs, and of course it's calculate the rainfall characteristics are calculated completely different. No reason for this. You either calculate soakaways in accordance with the index flood, or you calculate SuDs in accordance with the M560 data. But no, we've got two ways of doing it. Now, SuDs is designed on what's called the index flood. So if you ever hear about the word, the phrase Q bar, that's basically what it is. It's an index flood, and is calculated from the standard annual average rainfall for the area, which can be anywhere between 500 millimeters and 1200 millimeters, the area of the site, and of course the soil characteristics. And there's 4 types of soil characteristics identified within the SuDs manual. This achieves a value of a return period of 2 or 2.3 years, which is really crazy because, no, believe it or not, we've actually got 2 ways of establishing that. We can't even get the SuDs to do it in one way. It's one of 2. And then it's factored up by growth curves to achieve the return periods of 1 in 1 year, 1 in 30 years, and 1 in 100 years. The 1 in 1 year is for the frequent events, and the 1 in 30 and the 1 in 100 so, for the less frequent events, more what's the word I'm looking for? Extreme events. What it's trying to achieve? Well, it's trying to mimic the surface water runoff of a greenfield site. And basically, how does that happen? It happens through infiltration, through both deep and shallow infiltration. Now, we've got 2 types of infiltration. They depend upon the soil. If the soil is permeable, then the infiltration can go deep, and that will recharge the water level, the water table, to potentially create the base flow for the rivers. And the shallow infiltration is if we've got an impermeable soft geology, and basically what happens then is the water will permeate, the soil will be permeable to a certain extent, the topsoil, and then it will start heading south towards the water course, or some kind of ponded retention because of the topography of the area. The other thing that the greenfield site will lose water is through evaporation, either direct to the atmosphere or through vegetation, which is transpiration. Now, the SuDs people have invented a new word called evapotranspiration, and I won't even write it down. I'm sorry, I just won't have it. It's either evaporation or it's transpiration. It's one of the 2. But both of those can be quite significant. Some of the larger trees can take out a cubic meter of water per year from the soil, and we know that, you know, where trees have created problems in clay subsoils. So that's not unusual. Well, it's not unusual. It's not new knowledge, so to speak. And it also utilizes the moisture contents of the topsoils. They'll vary depending upon whether it's rained or not. If it's constantly raining, those topsoils will be saturated, and when the sun comes out, it'll dry them out. And the cohesive soils, they will store water, but they don't tend to transport it. So it may turn out that the top probably 300 millimeters of the clay subsoils may be affected by the rainfall, which we know it is to a certain extent, because that's why we have a meter deep foundations in clay, because we know that the seasonal moisture content changes there, and we get the foundations down a meter to get out of that particular movement. And what does all that do? It slows and reduces the volume of the runoff. And that's basically what we're trying to do. All the problems that we have with flooding is generally as a result of the runoff is too fast, or the volume of the runoff is too high. And that's basically, of course, you still have natural floods and you have natural floodplains, but they were never designed to be that way. So what are the factors that vary the runoff? Like I said, the degree of vegetation, depth of the topsoil, type of the subsoil, and of course the rainfall characteristics. If it doesn't rain, we don't have any runoff. It really is as simple as that. But we don't have that facility in the country, as you're probably well aware. So here we come onto the developed side, which is causing us all the problems. Well, it's not causing us all the problems, because some of the flooding problems are natural floodplains, but a lot of the flooding problems are created by development. So what's the problem? The problem is we have minimal infiltration, and because we covering the site with as many buildings as the planning department will allow, because that's the nature of development. We don't have that much greenery. We'll have the token. We'll have the token tree and the token bit of grass to get the development through planning permission. So you know the transpiration is minimal. Evaporation still occurs because evaporation will still occur up a hard surface. And basically what the above does, it increases the volume and the speed of the runoff to the receiving water of the outfall. And that's a major issue. The major issue for the lack of infiltration is it'll diminish the water table, so the ground source will be diminished. That could affect base flows in rivers. The pollutants are instantly washed off, so they end up in the receiving waters as well. So basically slow runoff and low volume is good, greenfield. Fast runoff and high volume is bad, that's developed. Come on, there we go. So consequences of the development. So it increases the downstream flood risk. That's what I was saying about volume. The increased volume tends to create less local floods, and they're like on the photograph of the introduction. People wandering around specific areas in 300 millimeters of water. If the pipe capacity for the conveyance of the water is limited, any extreme events will cause local flooding. So peak flow events tend to cause local flooding. They're the ones that pop the manhole covers off and stuff like that. So high runoff can cause damage to the morphology and the ecology of the receiving water, which makes sense. If the river's meandering and all of a sudden it's moving a lot faster with bigger volume, it wants to turn that meandering river into, so the erosion starts increasing, and the local ecology, which might be used to slow moving waters, is now exposed to fast moving waters. Polluted runoff, which happens on the high frequency event, also damages the ecology. And of course, what I've already said is there's a reduction in the groundwater levels as well. Right, I'm going to introduce you to interception. Interception is key to this, and this is the reason for interception. If you look, apparently this is a year. This really made me laugh. Actually, he said, "Oh well, this data was being collected from one particular place in a year." Now, if you don't like rain, wherever this is, don't go there. Just like if you don't want to get murdered, don't go to Midsummer, right? So if you don't want to be experienced by lots of rain, because apparently this is a place, and if you look at the number of events, we've got 12,000 events there, 12,000 rainfall events. Now, apparently 70% of them were all under 5 millimeters. And so what the philosophy is if we can deal with 5 millimeters of rainfall, then instantly we've dealt with 70% of the problem. And these obviously are the typical British small frequent events. And the small frequent events also is a major contributor to pollution in receiving waters, because the dilution of the pollutant is low. So we want to get rid of this for two reasons. It gets rid of it will solve a lot of volume issues in receiving waters, and it will also solve a lot of pollution finding its way into the receiving waters too. Just a quick map in SuDs, the average rainfall. And if you look at the right-hand map, if it's blue, it's high. If it's green, it's low. So for the love of God, don't move to the west coast of this country because you're going to get wet. Really, it's as simple as that. But what's interesting about this is, and on the right-hand side, that's the average rainfall. So the black is high and the red is low. And what's interesting about this is that the more chance that if you live in an area where there's lots, where the volume of rainfall over a year is high, you're unlikely to have high intense events. So you're going to have one or the other. So what the blue is there is the very high values of rainfall over a 100-year period, a 100-year return period, and a 6-hour rainfall. So these are huge. These are huge amounts of rainfall. And on the right-hand side, so on the left-hand side tends to be somewhere between 1 meter and 1,200 millimeters of rainfall. On the right-hand side, it's somewhere between 500 and 800. But on the right-hand side, you're more likely to experience a flash flood. High intensity, low duration event, and this will affect how you actually design your SuDs or how you actually design your soakaway. This is all taken into account on the numbers. This is a hydrograph, and this identifies a typical rainfall event. In the blue is a typical rainfall event in a development. No SuDs. So that's the start of the event. It starts to rain almost instantly. We have runoff, and it'll reach a peak relatively quickly. As a general rule, whatever the period, the duration of the storm, if it's a 30-minute storm, then peak intensity is generally halfway, 15 minutes into the storm. That's where you'll get your peak. So it's more or less reflecting how the rainfall actually drops from the sky. The red is how we've been dealing with that. So if we now say, right, okay, we'll put a big storage device before the receiving waters, attenuation tank, and we'll stick a hydro brake on it, a flow control device, which may limit the flow to 2 litres per second or whatever the local flood authority agrees. And that's the hydrograph you're going to get there. Again, instant, it's going to be absolutely instant, the response. It'll go up to a relatively low peak, but it'll maintain that peak. And that peak is whatever you set your hydro brake at. So if your hydro brake's set at 5 litres per second, that peak is 5 litres per second. And of course, that goes on for quite a long time. And what's consistent about that is the area under the blue, which represents the volume of the rainfall event, in both cases is identical. The difference is it just discharges for a longer period of time. Now, the green line is the SuDs line. So if you apply a good SuDs design, this is what you will achieve. So when the rainfall events start, nothing, because we're trying to infiltrate the first 5 millimeters through interception, and it starts there. Obviously, there's no numbers on it, and then it's slow, very, very slow, much slower than the rate of the developed site. It peaks at a relatively low level, and then continues on its base flow for a considerable period of time. So what we're trying to achieve is the greenfield route. The red is how we've been dealing with it. We're basically not putting many SuDs or infiltration devices into the design. And basically what's happened is you've got a development, lots of hard standings, one huge tank with a small hole at the end where the water comes out. It really is as simple as that. So like I'm saying, we really need to get again closer to this green line where we don't have any runoff for the start of the event. Now that's called interception. So this isn't absolutely accurate, but it's damned close. It's close enough for the purpose of this presentation. Interception is generally where the rainwater does not eventually discharge into the receiving waters. So that's either going to be through evaporation, transpiration, shallow or deep infiltration. Deep infiltration is technically not interception, but it doesn't get into the above ground receiving water, which is good. When the rainfall exceeds the above runoff, i.e. the 5 millimeters, which is what we're trying to achieve, then runoff's going to occur, but it's going to be slowed by the vegetation and the uneven surfaces within a greenfield environment. Obviously, within a developed environment, it'll just flow off those surfaces. And like I said, therefore, if you adopt these principles, only a percentage of the rainfall turns into runoff, and that's the case in greenfield. So as a guide, this is roughly 5 millimeters of rain. The idea is that on developed sites, we try and infiltrate that 5 millimeters of rain so it never ever finds its way into the receiving waters or the sewer or whatever. Now, you can't always infiltrate. So here's a few points where you can it. BRE 365 is when the water table can extend to the underside of the soakaway, then you shouldn't really have a soakaway, or your soakaway is too deep. You have it a bit narrow, a bit shallower. SuDs, when the water table is within 1 meter of the underside of the infiltration component. Now, that's more for quality than quantity, because what you're looking for between the underside of the soakaway, or this underside of the infiltration device, because it may not be a soakaway, and the water table is unsaturated soil, because that will filter out some of the pollutants. So that's the purpose of that. Now, I always thought it was 2 meters, but I looked through the SuDs manual this morning and it was actually 1 meter. Whoop. Regardless of the standard, where there's a risk of dissolution of soft bedrock, which is the mechanism of sinkholes, we've got a few of them around Welwyn Garden City, typical of soft limestones, chalk, and it's basically where the acid rain will start reacting with limestone and chalk and the calcium, I think it's calcium, I was going to say calcium silicate, it's not, calcium sulfate, is it? Can't remember, don't quote me on this. My chemistry is normally all right, but it's a calcium, I think it's calcium sulfate. Calcium chloride, that's what it is, I'm sure it is. But that's basically how the dissolution starts happening, and it starts creating holes in the soft bedrock, whether it's chalk or the soft limestone, and there's a possibility then of subsidence. And where the components over a protected aquifer. Now, you may get away with it, but it would be certainly subject to a risk assessment, and of course it boils down to the soft geology over the top of the aquifer. If you've got a lot of space between the aquifer and the underside of your device, you stand a better chance. Right, so we're going to move on to some green roof components. So how are we going to achieve all of that malarkey that I've just gone through in the last 16 slides? And everything's turned blank that was supposed to be checking my time. I'm not doing too bad, Trev, am I? On timing? You're muted, but I saw the thumbs up. Okay, well, the green roof, obviously we don't see many green roofs because, you know, unlike, you know, it's a bit like, can you imagine all green roofs on domestic, you know, just popping up to mow the roof, dear. You know, so you don't tend to see many green roofs on residential properties, but there's quite a few on commercial ones, and it's brilliant for interception, because you will lose 5 millimeters of rain in that green roof relatively easily. So what does it do? It reduces the peak flow, so it's going to reduce the local floods. It reduces the volume. It's going to reduce the more regional floods. It's going to provide treatment, so you're going to get an element of treatment before it seeps through into the disposal system. Encourages biodiversity, as you can see, and it could provide amenity. There's a bit of a footpath around there. It would be good if there was a bit of a park bench. You could eat your sandwiches and stuff like that. Would provide even better amenity. But it's a pretty good SuDs component. Rainwater harvesting, which is mandatory in Wales, and I think it'll be only a matter of time before it becomes mandatory on the largest schemes here as well. It reduces volume, doesn't treat anything. Obviously, there'll be some treatment between the runoff of the roof and actually find its way into your toilets, otherwise it's going to stain all of your toilets. No biodiversity, and not really much of an amenity. But the diagram made me giggle, I must admit. Me and Trev had a good laugh at it yesterday, where they put the collection, and so the tank's on the first floor, and it's, you know, that's great, because normally, as everybody who's done anything relating to this, you know, the tank's generally in the ground and then is pumped back up into the water storage tank, and I love a bit of services, but I don't like pumps where you don't need them. So it'd be great if we could actually get this, you know, this rainwater from the gutters into the tank, and it would work really well with monopitched roofs. You know, if the fascia is at a high level, then, you know, it's going to work. We'll be able to get that rainwater harvesting. We'll be able to get that into tanks in the roof, and then that will obviously provide a good head of water for all of your devices. Not that important if you've got a combi boiler or something along those lines, but you may need some water pressure. So it could work. It could work where where we don't go down, pump it back up again. And then we've got a water butt in there for matey dealing with his garden. He's watering the tree. What he doesn't know is that tree's already sucking all of the moisture out of the soil underneath his foundations, and his house is going to subside in the next 10 years. But I haven't told him. He's happy. Permeable paving. Oh God, I haven't changed that slide, Trev. I've got a comma in there after Will. Obviously thinking about Will Jones, one of our surveyors, but it says it will convey water. That's what I mean. So it will convey water, because sometimes if the sub base is impermeable, you would have to drain the sub base. But if the subsoil is permeable, obviously that would permeate into the subsoil. So great, it reduces peak flow. So straight away we've got a bonus there. It may reduce volume if it's used as an infiltration device. It's certainly going to reduce volume, and it's also going to provide treatment. We've got a couple of layers of geotextile membrane in there, which is going to hopefully filter out any hydrocarbons or heavy metals that might have been dumped on the paving. My favourite. I love a swale, and Elverton Heath in Fleet is full of them. Where I did a bit, probably 5 or 6 years on contract in that particular area, primarily to convey water. So basically, just looking at that, That probably replaces a 225 surface water drain, probably at 1 in 40 or something like that. Probably convey the same amount of water. Well, it's going to convey more, but the difference is that the pipe will convey it faster. And here's the difference between swales and pipes. Swales, we want the water to move slow. And the reason we want the water to move slow, because it'll drop the sediment out. That'll drop all the heavy solids out. And then matey comes along with a shovel and digs it out once a year. Now, pipes, you need self-cleansing velocity in the pipe, which is generally 1 meter per second minimum. So the pipe, the conveyancing in the pipe is going to be fast. And that's, that contributes to what I was saying about fast runoff times between the receiving component, the roof, and the receiving water. So basically what we're trying to do, we're trying to slow the whole process down. So that's how it reduces the peak flow, reduces the volume, provides treatment. It's constantly running through vegetation all the time, because these things should be running dry. They should be dry most of the year. So the trick is, if you're living in a development and the swale's wet most of the year, there's a problem somewhere, and obviously it's upstream. Downstream rather. Encourages biodiversity. You'll probably get every type of mosquito that's ever been invented breeding in there. I'm sure everybody will appreciate it in the houses. Sooner or later, all the reed warblers will turn up and eat all the mosquitoes, and that's the whole point of the biodiversity thing. I'm sure it's not as bad as that, but whenever I'm ever close to fresh water, I just seem to be bitten all the time. And of course, it provides amenities. You can sit and eat your sandwiches there in the summer. And it looks nice. It looks an awful lot nicer than a row of manholes. It's going to be serving a 225 sewer. Filter of the French drain. You'd be glad to know that the French didn't invent the French drain. It was invented by an American, which I'm really glad about, because I was really upset when in the HVAC world, where newtons per meter squared, the measurement of pressure was replaced by pascals. So I wasn't happy about that. Everybody talks about pascals now in pressure terms, and I thought, well, that's fair enough. The filter drains replaced the French drain. It's a fair swap. But apparently the French drain wasn't French; it was American. Primarily to convey water. Reduces peak flow, minor, possibly. It's going to reduce peak flow if there's a lot of infiltration, and again, it'll reduce volume if there's a lot of infiltration. And of course, it does provide some treatment. By the time that water gets to the receiving or the final outfall, it'll have a degree of treatment. It may have deposited some of the hydrocarbons and heavy metals into the granular surround to the French drain. 22. Bioretention. Obviously, we see these all the time in car parks. So obviously it's got a nice amenity value. It looks a lot nicer than the flat car park that goes on for a couple of 100 meters. Reduces the peak flow because you may get a bit of infiltration with it. Reduce the volume. Again, if you may get a bit of infiltration with it, depending upon the subsoil. If you look at the diagram, sometimes the underneath the bioretention filter material, the grown medium, so to speak, there'll be a drainage system that will eventually discharge into perhaps a swale or some other receiving body. Encourages biodiversity, and like I said, it provides amenity. It's nice to look at. It breaks up those boring car parks. retention basin. Oh God, I would have loved one of these as a kid. I would never have been out of it. Primarily to store water, long-term storage generally. Should be dry most of the year. If it's wet, there's a problem somewhere. Obviously reduces peak flow, reduces the volume, certainly provides treatment as that water's running into there. It will run through the vegetation into the topsoil, and with a bit luck, you know, it'll keep out. It will be, if the soils is what's the word I'm looking for? The soil's permeable, then if with a bit of luck, there's a huge difference between the bottom of the top of the groundwater, and you get some treatment there. And of course, look at it; it looks stunning. So it obviously provides the amenity. Attenuation tank. Oh, I've seen all of these, haven't we? We've seen lots of these. It's almost the go-to. Only stores water, and of course it reduces the peak flow because the outlet's going to have a hydro brake on it, or another flow control device. But to be fair, all the other flow control devices are prone to bung up, so that the hydro brake certainly is the go-to piece of kit. And speak of the devil, there it is, the hydro brake. So you can set that to any discharge that you want, whatever you've agreed with the water authority or the Environment Agency, depending upon where you're discharging your water and what's your final outfall. It's the first photograph I've actually seen of a hydro brake. Right, this, just to prove that it isn't, this is a scheme I was involved in 1995. And basically it was, if you look at it, let's see if I get my thing. If you look at it, we have a quite a large building, and what that is a training centre. So it's Sedgefield District Council's training centre, and most people, believe me, needed training in there, so that's why it's so big and it's got so many car parking spaces, because I work there. And basically it's obviously impervious roof and lots of car parking spaces, and that's tarmac. So a lot of impervious surfaces. So I run this through. Well, before I say it, I'll describe how we dealt with it. We could only discharge into that public sewer at the bottom, that 225 public sewer. We could only discharge at 5 litres per second. And we had probably, you know, the peak flow might have been somewhere close to 40 litres per second. And the capacity of the whole capacity of that sewer would be around about 80 litres per second. So, and Northumbrian Water said, well, it's no danger of that, you know, it's almost at capacity. So what the drainage engineer did, and if you can see it, I'm hoping you can see it, what he did, if you look, is zigzagged the drainage. And that, we didn't have attenuation tanks in those days, and we never even thought of attenuation tanks. We couldn't buy them even if we wanted them. And we zigzagged that, and that is 750 meters of drainage. And what they did was they put 600 diameter pipes in there. And that's 600 diameter pipes, and there's a little calculation at the bottom. The volume is 750 times pi r squared. R is 0.3 times 0.3, and it says 31.42. It should say 3.142. Obviously that's an error, just spotted it now. That gave us 212 cubic meters of attenuation. So we're getting up there. And then you chuck the manholes in, they're all 1800 diameter manholes. We've got another 50 cubic meters there. So the attenuation provided was 263 cubic meters. Now I ran that through HR Wallingford's storage estimation program this morning. that's available online. You've just got to register, and it said you needed effectively 750 cubic meters, but you could only discharge. Obviously, it was discharging at 2 liters per second, which is the get out of jail free discharge rate. If you can't comply with the SuDs requirement, then discharge at 2 liters per second. So that gave 750, and we've got 260, but we discharge it at 5 liters per second, and that's not a million miles away. The other thing was, as I designed this on a 100-year return period plus 40% climate factor. So which, you know, the drainage engineer at Sedgefield District Council certainly wouldn't have done that. So it's not a million miles away. I'll guarantee that flood occasionally, it might pop the lids off the manholes. So what would have happened, if I can find my mouse again? There's my mouse. There we go. What would have happened if we'd done it the modern way? So if we'd done it the modern way, what could we achieve? Well, we've already figured out that the storage requirement would have been 750 cubic meters, assuming 2 liters a second discharge. But if we stuck rainwater harvesting in, then I managed to knock 100 cubic meters of storage off for that. And remember, this is discharging at 2 liters per second, not 5. And then when I put permeable paving in there, managed to drop it down to 383 cubic meters, and the soil type is 4, which means it's a heavy clay. So you don't get if that had been a soil type 2, a kind of a clay sand, so to speak, then this would have dropped down to probably 100 cubic meters or so. So we even in modern standards, we could get that area down to, you know, about 400 cubic meters of attenuation, which is still big. You know, we could still probably stick a few more SuDs components in there just to solve that. Diddly, where's my? I'm getting close to the. And here we go, small domestic extensions. So I've got a small domestic extension. I'm looking at that on the left-hand side, and we've got a surface water sewer, and I've got, you know, 3 manholes around an existing building, and we put an extension out the back with a little bit of a patio and stuff. And because it's got a surface water drain, people will want to discharge straight into the surface water drain. Well, remember, the hierarchy is infiltration first. So, you know, even though that's a surface water drain, I've said surface water are combined, that's not the way to go. The way to go is initially through a soakaway, and it's under 25 square meters. So a cubic meter soakaway, you will have to try hard to design one and make it fail, because we only design it for 10 millimeters of rainfall in 5 minutes. So if it's a clay subsoil, then we need crates, and if it's a granular subsoil, then you'll get away with rubble. And then we can go a little bit flash for the last one. Stick a rainwater butt in there if the guy likes a bit of likes a bit of gardening and stuff. But what would be really good on the rainwater butts is that if you're not a keen gardener, like I'm not a keen gardener, it would be great to have like a 5 millimeter hole in there at discharge, and with a filter on it to stop, to make sure it didn't bung up. And then that would, you know, after a high intensity event, that would just slowly trickle into what I've called, it's like a flower bed, so to speak, into a bioretention unit there. And if we get another high intensity event, then it'll fill up and it'll just come out of the overflow and then back into this pipe again. And then you could grow rice in there, for argument's sake, you know, for example. You know, if somebody's into that kind of thing, because we've got a granular layer at the bottom, You know, it shouldn't flood the subsoil, the subsoil. So, you know, you'll get a little bit of infiltration on there, a little bit of interception on there, and then run it in. Ideally, even better still, it would be from that, and then bang it into a soakaway. You know, but I'm just kind of showing you different ways that you could adopt it. You can look at all of the different, you know, there's no reason, if you've got plenty of land, you could have a little bit of a detention pond there, a detention basin there, and drop it into a detention basin on the, you know, so it would be all on the surface. So, you know, there's lots of little ways to avoid getting that that surface water into that sewer, and especially the first 5 millimeters. Ideally, it would be great if we had legislation to say, right, you know, if you're putting an extension on, you've got to now take your whole building into infiltration if possible. And that would solve huge problems of local flooding and regional flooding and such like. But that more or less is the presentation. Oh no, I've got one more slide actually. I've got perfection.
Oh, Les, I was about to commend you for perfect timing, but you're just running over. So
mate,
let's be quick.
I never started till 35. I've got 4 minutes. But... I'll only take a couple of minutes on. This is perfection. This is Camborne, and it's been monitored at the moment for numbers. And basically, anything grey is development. All got rainwater butts. All find a way. All eventually finds its way into swales, and the swales the swale then finds its way into detention ponds, and they're linked with solid pipes where you can walk through, and then eventually it finds itself in a detention pond, which is the final cleaning of the water before it finds its way into the receiving waters. So, like I said, the things recorded, have a look through that. That's pretty, it's quite an interesting little scheme, is Camborne. And before I sign off, HR Wallingford are the knowledgeable people in this particular subject, and they run a 12-hour CPD online for £150. It's probably got to be the best value CPD on the planet. If you're interested in this, I would strongly suggest that you invest that £150. If you're struggling for CPD and you need 12 hours, you won't get it any cheaper than 150 quid. So there's two damn good reasons to join in on that. And that terminates it, Trev. Thank you, Les. Well, pretty near perfect timing. 58 minutes, man. And I don't know about best value CPD. Obviously, Hertfordshire Building Control provides that. So where you were going with that, I don't know. And also, I've got to say, this brainstorming about mini paddy fields in your garden with a 5 millimetre hole in the rainwater pipe, I think you might find that you need to be unbunging that quite a lot, Les. But it's an interesting concept, and you know, maybe we'll test that one out. But anyway, thank you very much. As always, really interesting, really informative. And, you know, I can watch these things twice and still enjoy them, which I've done. So thanks very much. There's no time for questions, I'm afraid. If you've got questions, and I know we've got one, ask just a simple thing, what's the difference between a ditch and a swale? But we'll answer that and any others in a subsequent mail shot to you all. Without further ado, be very patient. Let me hand over to Richard Taverner of Hearts and Beds Constructing Excellence to take things forward from here. Richard, if you'd like to take over the screen. Les, if you could stop sharing. And
Excellent. Thank you, Trevor. And thank you, Les, for your presentation. This afternoon, we've just got 3 bite-sized presentations to quickly run through. Each will last about 5 minutes. And then the first one of those is from Alison Nichol, who's the Head of Constructing Excellence. Hopefully, Alison is on. And this is where the system will work or not work. Calling Alison.
Hello, how are you?
Hello, Alison. Good afternoon to you.
Good afternoon. I'm just going to start my video. Hello.
Excellent.
Excellent. So I am here. Do you want me to share? just a couple of quick slides.
That'd be great. Yes. You want to share your
yeah.
screen?
So I shall attempt to make this work. I'm in a different setup today, so that could all be very interesting. Okay. There we go. Hopefully that is working perfectly. So thank you all very much for tagging us onto the end of such a fantastic presentation. You know, I think it's really critical that we start to sort out these issues like SuDs, etc. So for those of you who don't know, Constructing Excellence is a national movement that aims to disrupt the construction industry and transform the performance of the sector. We're there to deliver superior outcomes from delivering things differently, embracing new delivery models, etc. And I think within Hertfordshire, we've got Hearts and Beds Constructing Excellence Club that Richard is kindly agreed to take on the baton of chairing. And our club, we operate at a national, regional and local level, and our clubs are such an important part of what we do. So I'd encourage all of you to get involved in the Hearts and Beds CE Club, and Richard's going to talk to you about what the club has got coming up. A little bit about our vision, what we'd like to see from the industry, and I feel at the moment with the post-COVID recovery, the industry is moving in this direction. So we want to see a client-led transformation for procuring for outcomes and value. And we're starting to see that coming through with things like the value toolkit, the construction playbook, etc. Increased standardization and pre-manufactured content. So that's looking at how do we embrace MMC? How do we make sure we use the right things at the right times, etc. And then digitally enabled teams. So how do we embrace digitalization with collaboration to enable that collaboration and long-term relationships? Obviously, aligning commercial arrangements around that is hugely important, because my background is knowledge transfer, and technologies are, I'm not saying the technologies are easy, but it's actually those commercial arrangements that allow technologies to function and be installed and be procured in the right ways that really allows the industry to deliver those outcomes that it really needs to. So our current focus at a national level is around providing insight, so getting people to think differently, pushing those boundaries, inspiring them, so demonstrating the art of the possible within the sort of built environment context, and implementation, looking at practical implementation. What can you do on your project? What can you take away to implement that will make a real difference to your business? So our core themes are around digital, offsite manufacturing and technology, performance measurement. If you're not measuring it, how do you know that you're actually making that difference? Procurement, again, getting that commercial success set up is hugely important. And net zero, sustainability. Thank goodness it's come back onto the radar. It's a real push to enable all of the other transformation, but we have to start embracing that. We have to find new ways to deliver those sustainable outcomes. And thank goodness we're really starting to take that forward. So that is it from me, Richard. Let me just move over and stop sharing my screen.
Okay.
Oh, I hadn't shared.
There you go.
Okay. You managed. I don't think you needed the slides. You got me instead. So
excellent.
Yeah.
Thank you, Alison. Thank you. Our next one is from Phil Henry, who is the Build Environment Development Director at Genuit Group, and also sits on the Construction Excellence Management Board.
Thank you, Richard.
Thank you, Phil.
Just attempt now to share the screen, if I may. Excuse me a second.
Oh, that's okay. We'll let you know when it appears.
Yeah. No. Sorry about this. You should be seeing, is that sharing?
Can't see anything, no.
You can't. Okay.
We always like to have a few technical difficulties, Phil. Don't worry.
Yeah.
It adds to the entertainment value, so don't worry about it.
Right, let me get back to
It adds to the informality of these events.
You're
So,
doing better than me. I thought I'd shared mine and just started talking. So, you know.
yeah, apologies.
There we go.
Yeah, hopefully you can see that. Apologies.
Yeah,
no
we're there.
problem. You're in there, Phil. No
Sorry.
problem.
So a couple of slides effectively in terms of modern method of construction, in terms of polypipe offsite, which is part of the Genuit group. This is primarily looking at solutions for MEP, for the modern method of construction for factory built homes. So effectively what we're looking at here is how we can use digital in terms of digital twin for the MEP. So you can see these are digital skills are absolutely key to this, to understand the design and then building from that design actually in a factory as a sub-assembly to deliver into a factory. And in addition, it's looking at how on the right hand side you can see a board with some grey fittings on, where traditional ways of connecting pipework together can actually be made off-site effectively as well, saving time and also saving leakages in particular and quality. So effectively we'd look at the BIM model. We'd take out the MEP, as you can see there from the digital twin. That's why it's absolutely key. And these are being developed in factory settings for panelized or volumetric houses. And we're looking at productivity. So we're looking at reduction in installation time, self-contained frames, first fix effectively. And we're trying to use these with things like color-coded pipe work as well, which I can show you on this image. So this is a timber frame, which is, you can see everything then is fabricated. The pipe work is then red and blue for hot and cold. The soil pipes are all connected. The WC, the connections for the hand basin and the system. And on the right was a digital twin we actually built the left from, and that's via projection onto the factory floor, so that it can be made from that twin into a prefabricated item. That would then be sent to site and actually incorporated within the factory for both the modular or the volumetric. And again, the use of that digital twin and CAD/CAM is absolutely imperative to start with a level of BIM level 2 to start this process. As you can see, another example of putting these MEP boards together within the factory. And finally, if I can show you one here, is dealing with sort of complicated areas where we're looking at delivering the systems for high-rise houses, terrace units, but also supplying them as a prefabricated item, very similar to the car factory principle. So hopefully it's given me a little bit of insight into what's going on in terms of delivering MEP within the modular world.
Excellent. Thank you, Phil. Nice. Now, if you can unshare your screen.
Yeah.
You go to the top. I think there's a. That's
Yeah.
it.
Yeah.
And I can then share my one. Let's go up a bit. Excellent. So I'd just like to say a few words about the Construction Excellence Club. It's going to be divided into kind of 4 main areas, really. I want to kind of just briefly kind of look back to see what our journey so far has been. I want to then kind of cover what we are planning going forward. a little touch on membership in terms of becoming members of the actual club and supporting your club in Hertfordshire and Bedfordshire, and then a comment on next steps. So our journey so far, at our peak, we were up to about 50+ members a year. We were founded back in 2005, which is when I first became involved in the club as the chairman. Since then, there's been 5 chairmen. We've actually organised and run over 100+ events. We've worked closely with BRE and looked at site visits as well. And during the early parts of the years, we actually looked and developed a work experience programme, looking at schools and careers advice. And then we went on to develop that into a student mentoring programme that took students who were, I think, at a university stage or just going about to university to expose them to the construction industry. And that was very successful. We had local East of England National CE Club Awards and got involved in that process. Members of the club became very collaborative and actually worked together on projects. And we actually won an award for one of our projects we worked together at the national level. And we also linked up with Hertfordshire Chamber of Commerce and joined forces with the Chamber. So what are we planning? We want to relaunch the club. It is a time now with the COVID and other crises. I think we need to re-engage in hearts and beds. And we are looking to kind of re-establish the membership from before and actually increase the members. We are looking to run 4 CPD accredited events each year. We want to develop a building visits program as well to go and see developments that actually have either won awards from Construction Excellence or have innovative ideas that we can actually share. We're looking to re-establish the network opportunities across all the construction industry in Hertfordshire and Bedfordshire, and meet and develop the relationships between members, and also tap into the resources of construction excellence nationally as well. And of course, sharing of best practice and innovation. And then finally down there, I'm also very keen to look to see how we re-engage with the educational side and look at how we actually develop the engagement with recently qualified professionals in the construction industry and how we actually can develop up some educational learning for those individuals. So membership. So what does it actually include? It will include attendance to all the events with the CPD certificates. It gives access to top and change-making speakers and projects, the sharing of experiences and best practice solutions, and links with other members in Hertfordshire and Bedfordshire. Access to construction excellence and the annual awards. And as a one-off, like all membership, as we're really trying to focus and relaunch the club, we've got a one-off special of 18 months membership until the end of 2022 for the cost of 12 months. And then the membership will run annually thereafter. So for individuals, it's a £50 membership fee. And for corporate companies, it's £150, but gives unlimited attendances to any of the events. So next steps. So we got some key events coming up. We've got a couple of events that actually are now starting to be programmed in. The first event will be at the end of July, which is going to focus on the Stevenage Regeneration Project. This is hopefully going to work into an annual event where we can actually follow and learn more about the redevelopment of Stevenage's town. I mean, there is, I think, statistically wise, 1 million square foot of new build going on there, 1,239 new homes, shops, restaurants. It's complete redevelopment. So we want to get involved in that, and we want to understand that the new developments for Stevenage. And in September, we have Kevin Thomas coming to talk about the IPI model, the integrated project insurance, which looks at inclusive collaboration in the construction process and the removal of barriers for integrated working. So 2 key events already programmed in, and we are looking for other events into this year and into next year. So next steps, contacts for membership. If you want to be involved in the committee or want to be a speaker, contact us as well. And if you wish to host a sponsor event, also get in touch. And then talk to colleagues and make them aware of the Hearts and Beds Construction Excellence Club and the CPD events that will be running locally as well. So it's an exciting time really to relaunch Hearts and Beds Construction Excellence. Thank you very much.
Well, thank you,
That's
Richard.
it. Thank you, Trevor.
And it's been a pleasure to have you along. And it's clearly really important work you're doing. And I think with you at the helm, we really hope that the whole organisation be reinvigorated and attract new membership. And because we share synergies with you share synergies with HPC in what you're doing. So
we do.
Very best of luck to you in that. So that concludes the event. I've got to say, it's good to see how Construction Excellence is focusing on the offsite sector. We certainly we're doing the same. We're aligning our service towards it. Love it or hate it, it's a building wave that is coming to shore now, and we've all got to adjust, including building control. And we are working at a national level to set ourselves up so that we can work successfully on those sort of projects. Thank you then, Richard, Alison and Phil, for your presentations. Thanks again to Les for his, and thanks to everybody who attended for you taking the time to join us. As always, we hope you enjoyed it, but if there are any topics that you think you'd like us to cover, then we love to have suggestions, and then we can run with those. But Rachel, next event, we've got an event with the BBA scheduled, I think, for September. But have we got a date set on that yet?
It's tentative for the 15th. But...
Excellent. So that's on the stocks. We'll have a bit of a breather, and that's 15th September. BBA, and we'll be probably talking about the UK CA mark and how it's taking over from the CE mark, and the ramifications for the construction industry and for building control. So a really interesting one there from our neighbours, the Agrimont board. That's it then. Thanks again for joining us, and we hope to see you at that one. Rachel will keep you advised of what's going on, and in the meantime, take care. Bye for now.
Thank
Thank you. Bye.
Thank you.